Now let us start with the third unit. It deals with how to write an assembly language program, and then it is followed by the concept of stack, interrupts and macros. Now let us start with concept of programming with an assembler. So before going to this concept, that is programming with an assembler, first of all we have to recollect the three levels of language, that high level language, assembly level language and then low level language. High level language are the one we can easily able to understand and write the program, whereas in assembly level language it is somewhat difficult compared to high level language. And then the low level language are the machine codes that are easily understood by the underlying hardware or the machine. Whenever you write down a language using a high level, whenever you write down a program using high level language, it is converted to assembly level language using the compilers and interpreters, and from the assembly level language it is converted to the low level language using assemblers, linkers and loaders. So this is how a program written in high level language is easily understood by a low level underlying machine. So next we will discuss about the advantages of assembly level language over machine level language. So machine language are the ones that are made up of machine codes in terms of zeros and ones, which are often difficult to remember by the programmers. So compared to the machine level language, assembly level language are the more easier ones and are more user friendly. So the first advantage is that there is no machine codes. There are only instructions or the assembly codes or the mnemonics that are easily understood by the programmers, and it's not time consuming. That is, reading the opcodes is not so much of time consuming when compared with the machine level language, and the chances of errors are less because we can able to easily understand the meaning of the coding, and then debugging is easier. So we can easily sort out wherever an error occurs, so that it will be easy for the programmer to find out error and make the debugging process easier. Next, it is user friendly and it stores the results in the user friendly manner. That is, with the help of registers available in the microprocessor, it is easy for any programmer to store the results in an easily understandable and user friendly manner. And there is flexibility of programmer. Then based on the application, the programmer can easily able to write down the coding. There is no restrictions or no limitations in write down the coding. So when compared with the machine level language. So these are some of the advantages of assembly level language over machine level language. Next is the some of the assembler tools, that is we can. So next is the some of the assembler tools available. They are MASM assembler, that is Microsoft Macro assembler, then Turbo C assembler and then DOS. So these are some of the assembler tools through which we can write down the assembly language coding. Now let us take into example, that is we are writing an assembly language. Suppose we are writing an assembly coding using MASM assembler. There are certain steps such as entering the program, assembling the program, linking the program and debugging the program. So entering the program means you can write on the program listings, that is the program code in the editor. There are lots of text editors available such as NE, Norton's editor, then Edlin. There are a lot of text editors available, that is NE, that is Norton's editor, and then Edlin and etc. So these text editors are used to write down the program listing, and the program listing will be saved under a name. That is, a file name should be given for that a particular text editor and it will be saved in that notation. So this is the process of entering, that is entering the program in the text editor and saving it with the file name. Next is the process of assembling. So assembling process means it's whatever a program you are given to this process, it takes the process or it takes the file name with an extension .asm. If the file name does not contain this .asm extension, then the file won't be considered for assembly process. So in our example, let us take that example, that file name as sample.asm. So this sample.asm file will be given to the assembly process, and the assembler will assemble all the program written in that file, that is sample.asm, and produces the .abj file as output. So the process of assembly is it takes .asm file as input and produces .obj file as output. And the third process is the linking process. For linking process, it takes the input of sample.obj file as input and produces sample.exe file as output. So it produces the corresponding object code modules for the .asm files, and it produces the .obj files, that is object code file. And for debugging, so this debugging process refers to the troubleshooting process which takes the sample.exe file and sort out the errors present in that file. For this purpose, it makes use of debugging process. So these are all the 4 processes that should be occurred in step-by-step manner when executing an assembly language program. So summarize up, first process is the entering the program, that is entering the program and saving it with the .asm extension, and next is the assembly process. It takes .asm file as input and produces the corresponding object code module with the .obj file as output. And for linking process, it produces the linker modules and it takes that .obj files as input and produces .exe files as output. And debugging is the troubleshooting process which takes .exe files as input and produces the corresponding outputs in a directory. And make sure that for executing these steps, the corresponding assembler tool, that is MASM, should contain the text editor ne.com, and for assembly process MASM, then for linking process link, and for debugging process debug. All these tools are available in the same directory of that corresponding assembler program. So this is how an assembly program can be written and executing using a software assembler tool.